single operating system, in a single operating systems. But in your real-time scenario, in your organizations, you are not supposed to use any single operating system, guys. There will be a multiple operating systems, multiple applications will be running on the top of that. Now, let's see. If I do have a multiple OS, on the top of the OS, I will be using my containers. Suppose there are only 3 operating system, if I will tell you. Okay, only 3 OS which is being running in my organizations. I'm just giving one example. So on the top of that, I will be having containers. Suppose I'm telling you C1, C2, C1, C2. So these all are the containers which are running in the OS 1, 2, 3. So at this moment, if this container wants to communicate with this container, they can able to talk, because this container will have in the same, they are in the same network. If this container wants to talk with this container, they can also. If this container wants to communicate with this container, they can also communicate. But at this moment, this container wants to communicate with this particular container. This OS are in the different network. This communication cannot be established, guys. This communication cannot be established. So we will be discussing how these containers are going to get the IP addresses. This is the OS. This OS is having IP address, but how this container is going to get the IP address, as it is running as a process, right? VM in this is my OS on the top of the VM. As this VM is having its own kernel, we are going to create one interface for this particular VMs. This VM is going to get the IP address, but this container is running as a process. But how this container is going to get the IP address? I told you this container will behave as a virtual machine itself for a developer to deploy the applications. As the developer is going to log into this particular container, that means container must have one interface, or the container must have an IP address through which the developer is going to log in, right? So I will tell you on the time when I will be discussing about the Docker, how this containers is going to be get, or how these containers are going to get the IP addresses, because this container is running as a process. I also told. So how this is going to get it, I will tell you in the Docker classes. So let's come to the point that this container, if they want to communicate with this container, they can able to, but this container won't be able to communicate with this container just because it's having a different network. So different ranges of IP address, so they won't be able to communicate. But this shouldn't happen in the organizations, guys, right? In organizations, every container should communicate with another container. Suppose my front-end application is running here. Suppose the front-end application is running in this container, and my backend DB is running in this particular application, and backend DB application is running in this particular container. So this front-end and backend DB should communicate, right? But at this moment, if the container has been deployed in the different operating systems, this communication cannot be established just because it is having different network. So to overcome such kind of problem or drawbacks, we came with a new concept called Kubernetes. Let me just go ahead and try to make you understand about the Kubernetes now. Because guys, this OpenShift under layer of Kubernetes only. Okay, Kubernetes. So this OpenShift under layers is Kubernetes. That means by using the Kubernetes source code, the Red Hat people, they have built the OpenShift. Okay, I will tell you that point. So now let me just go ahead and discuss about that. So now we do have a new concept that I just have told you called Kubernetes. So now to overcome such kind of problem, the communication problem between among the containers, we are coming with a new concept called Kubernetes, which will help us, not only help us for the communication purpose, but also it will help us to manage or to manage our infrastructure. So it's just an orchestration tool, guys, I would say. As we do have a containerization tool, this Kubernetes, we are calling it as an orchestration tool, okay, which is going to take care of the infrastructure where the application has been deployed. Okay, and on the top of this Kubernetes, we are now not calling as a container, we are calling it as a pod. Okay, we are calling it as a pod. So on the top of this Kubernetes, multiple pod can be deployed. Multiple, according to your resources, you can deploy your pods. And what is this pod? Pod will have multiple containers. Now, if you will say This pod is having containers. That means only one? No, guys. So pod can have multiple containers. C1, C2, C3, whatever the containers it can hold. Suppose if I want to do the replicas, I will tell you in the OpenShift classes what is replicas. If you want, you can create multiple pods as well at this moment. So you can just go ahead and do the replicas. You can set the replicas for a deployment to create a multiple pod at this moment. So now I don't want to make you confused on that point. So, but just try to understand about the pod, what exactly this pod is. Pod can have multiple containers. Now the containers will hold the applications, but here we are not telling that container is holding the applications. We will always tell that pod will hold the applications. That means whenever the developer will go ahead and deploy the applications on the top of the Kubernetes, the pod will automatically hold that application. But in depth, if I will tell you, pod will hold the container, container will hold the applications. Okay, ultimately the applications will run in the container, but I will always tell you guys the pod is running and the pod is holding the applications. But you will think that inside the pod we do have container and container is holding the applications. Fine. So now this pod communication can be established, guys. Though it is in the different network, this pod is in the different network, the communication can be established. I will tell you in the networking class of OpenShift that in the networking classes in the OpenShift, we will be discussing how this pod can able to communicate with this pod, though it is having different network. Now, suppose this pod is having different ranges and this pod is having different ranges. This can able to talk with this pod as well. But if you, I will tell you just in the brief way, actually the pod will communicate in such a way that we do have a tunneling method in the operating systems. Through the tunneling method, they will be go ahead and talk in the backend, something like this will they will talk. Okay, in by using the tunneling in the each and every OS, the tunneling method, this pod will communicate. But I don't want to make you confused for now. But just understand that pod can communicate with each other. But yes, if you want to restrict that pod shouldn't talk, this pod shouldn't talk to this particular pod, we can also give the policies, or we are calling it as a network policies. We can break the communication between those two pods as well. So we do have that features from the OpenShift and the Kubernetes also. Fine. So for this, now I told you, not only for the communication purpose, we are creating this, or we are having this Kubernetes. Kubernetes is an orchestration tool, guys. It will not let your application to be down. If suppose there's something happened and my pod is going to be deleted or my pod is going to be crashed, at this moment, the Kubernetes will take care of this particular pod and it will go ahead and automatically create one another pod there. Okay, there is a restart mechanism. It will always do the restart whenever the pod is going to be deleted. So after restart again, if this pod is not coming up, then it will just go ahead and create one another pod having the same content, having the same applications. Okay, so this is what also been taken care by the Kubernetes. It's a orchestration tool, I'm saying it. So not only that, we have huge features in OpenShift and the Kubernetes, which will help us for a developer to deploy the applications and managing the applications as well. Deploy is simple, but managing application is quite difficult, guys. But for now, by using the OpenShift, it's very simple because everything is being taken care by the OpenShift. Okay, so we have discussed about the Kubernetes, but why we used to use this OpenShift? Just because most of the companies, they are not going to use Kubernetes because Kubernetes is a source code. Sorry, Kubernetes is a community-based applications, like community-based orchestration tool that it's a open source. But companies like any banking, any airlines companies, they are not going to prefer this Kubernetes as is a open source, and there may be a chance of hack. So at this moment, they used to prefer OpenShift because it's an enterprises one, it's a Red Hat product, and the support is far better because anything happen to your clusters, anything happen to your infrastructure, you can just inform to the Red Hat people. They will just come and the Red Hat support people, they can just come and solve your problem. So you must have to reach out any problem. You have any problem in your infrastructure, just reach out to the Red Hat people. They can just come and they will solve your problem. So that is the reason most of the companies, around, I could say 50 to 60,000 plus customers are there for OpenShift from the Red Hat people. They're taking the OpenShift from the Red Hat. Okay, around about that. So as it is I could say Kubernetes, as it is a open source and community based containerization tool, most of the companies are not going to prefer. They will be using the OpenShift. And what OpenShift, how this OpenShift can, and what Red Hat people have done by using this Kubernetes source code, they have deployed a new orchestration tool by adding some extra features, and we are calling it as a OpenShift. Okay, by using the Kubernetes source code, they have added some extra features, guys. I wouldn't say that what are the features we do have in the Kubernetes, the same features are there. No, OpenShift is having extra features that has been added on the top of the Kubernetes as well. That also we are going to discuss when I will be telling you about the product, about the OpenShift. Okay, what all are the features we do have this OpenShift. So this is what the OpenShift we do have, and the OpenShift also we do have multiple pods. Like the developer can deploy the applications on the top of this OpenShift infrastructure by using the by deploying the applications inside the pod itself. Okay. Yep. So this is what the OpenShift is. The enterprises one. The just give me a moment. Fine. It's an enterprises product, and it's a Red Hat product, I would say. So anything happening to your infrastructure on the top of the OpenShift, you can just contact to the Red Hat people. They will be coming in your remote and they will be solving the problem. So that's what I would say. And also I will be discussing about that is what the OpenShift, and this is how the OpenShift is came. We are not ending here, guys. We also are going to discuss about the extra features. We are also going to discuss about the thing that is being related to our OpenShift in our nearer future classes. But for now, I will just go ahead and we'll talk about what all are the topic that we are going to cover. So let me just go ahead and show you the topic. So this is what the book that I will be sharing with you. So Red Hat OpenShift administration, operating in a production Kubernetes cluster. So the topic that we are going to cover in the OpenShift is there are around 8 to 9 chapters we do have. So these all are the chapters we are going to cover. So let me just give small intro about this topic. I'm not going in depth, but I will be just telling you what exactly the topics are, and what all are the things are there inside this topics. The first topic I would say, guys, the first topic that we are going to discuss here is describing the Red Hat OpenShift container platform, where we are going to understand about the product. We are going to understand about what features we do have and what extra features we do have on the top of the Kubernetes. And also we are going to see the what OpenShift is and the architecture of OpenShift as well. Okay, how exactly this OpenShift has been built, what all are the master node, worker nodes. Okay, we will be discussing it in the chapter number 1. And in the chapter number 2, it's a basic chapter where we do have some basic commands, and we are also going to do some troubleshooting after deploying the application. Suppose developer told the administrator that I have tested this applications in my test environment and it has been running fine. But whenever I'm deploying this application in the OpenShift production infrastructure, the application is in the pending state. The application is not going to be deployed. At this moment, the developer will reach out to the administrator, and being the OpenShift admin, we will just go ahead and do our basic troubleshooting to spin up or to up our applications at this moment. So that part we are going to discuss in the chapter number 2. And it's just a basic troubleshooting part. And also we are going to discuss about the OpenShift dynamic storage. So OpenShift dynamic storage means what? Whenever the application is going to be deployed inside the pod should have some kind of storage inside that. But how exactly this storage is going to be used inside a pod to hold the applications, that we are going to discuss in this chapter number 2 as well, by using the OpenShift dynamic storage inside your, if some as an administrator, Linux admin, you guys know that in your Linux VMs, you must have some file system, something. If you guys are going to use some NFS, you are using some LVMs, right? So to use the this file system or to use the data about your applications. But in OpenShift, how exactly this storage can be used, that we are going to discuss in this dynamic storage. In the chapter number 3, it is about authentication and authorizations. The name itself defines that authentication means how exactly the customer, sorry, how exactly people or organizations employees can able to log into their clusters. What after logging to the cluster, what level of actions they can able to do, that is called as authorizations. Authentication, how exactly we can authenticate to the clusters. Authorizations, after authenticating to the cluster, what level of action or what role is given to the user, that we are calling it as authorizations. In Linux, we do have user management topic, that we can go ahead and use the, we can add the user inside the server, then the user will get the access. Or we do have a different LDAP concept or active directory we are using, through which we can give the access to the particular user to access to our VMs. But in OpenShift, it's quite different, guys. On the operator level, on the cluster level, we are going to make the changes. We are going to give the access to the user. So that part we are going to discuss in the chapter number 3. It is authentication and authorizations. Coming to the chapter number 4, it's configuring the application security. So how to secure our applications, how exactly, I told you, this is an enterprises one, and Red Hat always tried to secure the customer applications in their infrastructure. So in this application security, we are trying to understand about how to secure our applications and about the security context constraints, SLNX. These all are the parts we are going to cover in the chapter number 4. And chapter number 5 is all about your networking. I just told you the pod communications, though it is having different network, how exactly the pod can communicate with another pod. And not only that, we also are going to discuss about some exposing the application to the external world. So once the application has been deployed in our clusters, how the external customer can access to this particular applications, that also we are going to discuss. Chapter number 6, controlling the pod scheduling. In this chapter, we will be discussing about once the application has been deployed by the developer, this application, where it is going to deploy it. We do have such worker nodes, in which worker node it should deploy. And after deployed, suppose I do have a multiple customers. Now, if I will be giving one example, I do have, suppose this 2 nodes where the application has been deployed. Suppose 2 pods where the application has been deployed. I'm sorry. One sec. Yep. So I do have 2 pods where the application has been deployed. Now I do have a less number of customers, but tomorrow I do have multiple customers. At this moment, I wanted to increase my pod because the communication, whichever it is coming to my pod, it is less, it is more. So that I will just go ahead and increase one another pods. So that part we are also going to discuss, okay, in the chapter number 6, in the pod scheduling. So we do have auto scaling as well. If somebody have some idea about the AWS auto scaling part, so don't worry about that. We are also going to discuss in the chapter number 6, the auto scaling part as well. In chapter number 7, we are going to discuss about the cluster updates. What all are the releases we do have from the Red Hat, that we are going to discuss in the chapter number 7. So suppose if I do have a 4.5 of clusters and I wanted to update or upgrade the cluster to 4.10, how exactly that can be done. So that we're going to discuss in the chapter number 7. In chapter number 8, this is the best thing that I'm going to tell you guys, that in OpenShift, if somebody wants to deploy the applications, the people don't, if somebody doesn't have the idea about the command line, they can use the graphical user interface to deploy their application. Suppose being a developer, only they know the codes, okay, but administrator knows the commands and all about the OpenShift. But as part of developer, if they don't know about the commands, they can just go ahead and log into the web consoles. Everything will be in the GUI, graphical user interface. They will just use the OpenShift web consoles to deploy their applications also. So this is the best part I could say, which has been given from the OpenShift or from the Red Hat people. This is the features that has been added to the OpenShift, is they can use the web consoles to deploy their applications. Like if I'm a developer, I don't have any idea about the command line of OpenShift. So what I could say, guys, I would go ahead and log into this particular web consoles. I use only in the GUI method. In the GUI method, I will just open and I will deploy my applications. So that part also we are going to cover in the chapter number 8. So what all are the things that can be done in the command line? The same thing can be done from the GUI also. And people always prefer, instead of command line, they will always prefer the graphical user interface. So this topic will be more interesting, I would say. So we will be discussing about that web consoles part. And chapter number 9 is something like compressed review. That means what all are the things that I've discussed till chapter number 8. So it is just discussed in the gist part. Okay, fine. So these all are the topic that we are going to discuss in our nearer future. So while we will be scheduling our batches, this part we will be covering. Okay, in every chapters we do have multiple sub chapters, guys. If I would say, and also I would tell you guys, in each and every chapter we can see one guided exercises, right? So this guided exercise is nothing but the lab environment where we're going to go ahead and practice this exercises. Okay, I will always tell you to practice this, listen to the class, listen to the recording sessions, and do practice. You can easily get the OpenShift, what OpenShift is, guys, I would say. But if you don't practice, I'm telling you guys, you won't be able to understand everything. I'm telling you. So practice is must required. Listen to the class. That is enough for the OpenShift, I would say. Okay, fine. I'm done with my demo. If you have any questions, please let me know. Any questions? I will just take a pause and will ask. Yeah. Any questions anyone have? No questions?